I will explain the introduction for vector and scalar. Vector. Vector quantity has both magnitude and direction. Seconds, vector quantity can be 1, 2, or 3 dimension. Example, displacement, velocity, acceleration, force, and momentum. Next, the scalar. The scalar quantity has magnitude but no direction. Second, every scalar quantity is one dimension. For example, speed, length, area, volume, time, mass, density, and energy.
So now I will solve a vector and scalar question which is linked to electrical engineering. Now a rectangular coil ammeter of a DC motor is placed between the north and south magnetic poles as shown in the diagram above. A current flows through the coil producing a magnetic force that causes it to rotate. So the magnetic field acts from north to south and the current in the left side of the coil flows upward. The magnetic flux density is 0.5 and the velocity is 3I plus 2J. The current through the coil is 4 ampere and the radius vector from the coil center to the site experiencing force is R equals to 0.05I plus 0.02J plus 0.01K. So now the question is A. The coil experiences two equal and opposite magnetic forces on its left and right sides, and determine the angle between the magnetic force and the coil's velocity vector. And lastly, C. Find the torque acting on the coil using the cross product. So now let us look at question A. The coil experiences two equal and opposite magnetic forces on its left and right sides by using the formula given, which is Fr equals to F1 plus F2. So now we know that this is the F1 and this is the F2. So since the formula is given, it is much more easier. Fr is equals F1 plus F2. So it is equals 0.2I plus 0.3J plus negative 0.2I plus 0.3J. And now we can see that 0.2I and negative 0.2I, if they add together, they will get 0. So we can just ignore it. So we can just solve J. 0.3J plus 0.3J. So we will get 0.6J for the FR answer. Now let us move on to the next question to determine the angle between the magnetic force and the coil's velocity vector. So the formula is given here, which is the dot product formula here. So now F1 dot V is equals to this cos theta. So first of all, we need to find the value of F1 dot V, which is 0.2 multiply 3 plus 0.3 multiply 2, because the formula the value of V and F1 is given here. So now let's solve it. So we will get 0.6 plus 0.6, so we'll get 1.2. So now let us find the modulus F, which is 0.2 square plus 0.3 square, and we will get 0.13, and If we calculate it, we will get 0.36. And now for the modulus V, given 3i plus 2j. So it is 3 squared plus 2 squared. We will get 13 cert. And last we will get 3.61. So now we have all the values. Now we can use the formula of the dot product formula, right? So f1 dot v equals f v and cos theta. So the formula of f1 dot v is 1.2, and both of these is 0.36 multiply 3.61 and cos theta. So if we multiply both of these, we will get 1.3 cos theta. So cos theta is equals to 1.2 divided by 1.3, and we will get 0.923. And then to find the theta, we're gonna use the inverse cos, so 0.923, and we will get the final answer is 22.8 degree for the angle between the magnetic force and the coil's velocity vector. Now for the last question, we need to find the torque acting on the coil using the cross product. So the formula is given here, which is the torque is equals to F1 multiply R. So for this, we're gonna use like the matrix thing, which is F1 multiply R. So T we will get I, and then 0.05, 0.2. For J, you will get 0.02, 0.3, and lastly K, 0.01 and 0. So now we need to find the T, the torque. So which is 0.02 and 0.3, 0.01 and 0, and minus J, which is 0.05, 0.2, 0.01 and 0, and last is the K, which is 0.05, 0.2, 0.01, 2, and 0.3. And then we will get, so we need to cross multiply it like this, 0.02 multiply 0 minus 0.3 multiply 0.01 minus J, 0.05 multiply 0 minus 0.2 multiply 0.01 and plus K, 0.05 multiply 0.3 minus 0.2 multiply 0.02. And now we will get negative 0.03i plus 0.002j and plus 0.019k for the final answer. Thank you.
For the conclusion, scalar and vector quantities are important in electrical engineering because they help analyze and understand how electrical and magnetic force works. Scalar show magnitude only, while vector show both magnitude and direction. In a DC motor, vectors like force and torque are essential for explaining how rotation happens.